there were contributions to this paper by my co-worker Daniel Torsello. So my position is still officially Senior HPC DevOps Engineer, but basically these days I'm mainly looking after the HPC support team. So we had a bit of a reorganisation, that's where I ended up. I have done a few talks in the past relating to HPC education. One of the, just before that I was doing sort of like more on the area of various like tools for sort of like, collaborative technologies for HPC, but then I basically moved directly into the HPC education space. And as you can see there, the first presentation was given at eResearch New Zealand Symposium before it was actually technically a conference. I think that one I turned up to on the day. I just so happened to be in Dunedin and found out that it was on, and I said, hey, can I give a paper here? And with like 1 day's notice, I put something together. And that was just after I'd stepped into the space of, that was at the Victorian Partnership for Advanced Computing. But as you can see, there is a long history there of saying, what is it that we need to learn from the high-performance computing space that aids researchers at getting their research done in a timely and improved manner. And it's been a very, very interesting journey, which I may add included studying at Masters of Higher Education at Otago University. And there will be bits and pieces in here that particularly come from the last paper, Tailoring HPC for Medical Research. So, yeah, take the opportunity to look those things up at your leisure. They're all available. And you could be able to see the involvement in the international HPC certification and the debate about whether to use tools, make the interface easier or skill up the researcher and things like that. That's actually become a big focus because one of the questions that always comes up is whether we go for skilling up the researcher or trying to find a new framework for people to work with. And I'm very much in favour of skilling up the researcher because getting them to know the fundamentals allows them to elaborate in their own manner and in an environment which they understand in their own domain. So, what have we got at UniMelb? Well, UniMelb's a really interesting little institution in its own right, insofar that it's got these nice little collaborations with these various health institutions that surround the university, and also apart from the fact it's got its own bioinformatics tool, school, and it's got ag science as well. So. This is from late last year, the Walter and Eliza Hall Institute, Peter MacCallum Cancer Institute, Murdoch Children's Research Institute, and UniMelb itself. UniMelb's system there is Spartan. I've given many talks about Spartan in the past, which weren't on that last slide. Spartan was our general purpose HPC system, which started off with a couple of hundred physical cores and maybe 1,000 cloud cores attached to it, and has since grown and expanded and is now one of the top 500, number 250 something in the world, and that's just for the GPU partition. So that's grown and done stuff that's pretty amazing. So that's basically the hardware that we've got that's available in the area, and as from that you can probably start to guess the very large number of researchers who rely on our compute power to actually make the changes that we need. One of the things, of course, about the term bioinformatics, and I've given a simple definition there, is that really it's almost as redundant as the term e-research. It is hard to do anything in the biosciences that does not involve a computer these days, and does not involve computation or data analysis. I mean, sure, you've got sort of like a workflow that sort of like says, yes, I've come up with this in the simulation. Can I compare this with the empirical data? Maybe somebody does the empirical data side of things, but really, human beings, researchers tend to do a little bit of it on their own. And at cryogenic electron microscopy, for example, I mean, that is, in terms of like data, that's like 75% of the university's data movement in its own right. It's just absolutely massive. So you can see the groups there that are at Uni Melbourne and the precinct that I mentioned previously. The Melbourne Bioinformatics group is quite interesting. Former VLSCI, it's the Victorian Life Sciences Computer Initiative. They had a very powerful machine and training program as well, which I've got to say they got a lot of content from what I'd given in the past. They once had one of the major IBM Blue Gene system, and this little story behind that was when the VLSCI no longer had its after the government funding expired and couldn't get the universities to support it. They tried to give away a top 500 machine, and they couldn't find anyone to even just accept it. We tried to offload it to New Zealand a couple of times. Eventually, a tech institute in India said, yes, we'll have it. And then, and I love telling the story, and then the Indian government said, no, you're not allowed to accept this supercomputer because it is second-hand. And that would be, they had legislation that prevented junking old machines into India, which is fair enough. But I bet they didn't think about supercomputers at the time. Anyway, so these are the groups that we draw upon our research base. These are as you can see, it's very heavily based on the health sciences, but not exclusively so, right? But that does provide, a fairly large component of the work. So a lot of these researchers are used to using web tools. One of the Galaxy is a very popular tool. They're quite often unfamiliar with command line tools. They are unfamiliar with those basics like HPC tools. And I've noticed over the years that this has always been the case. Right? Somewhere along the lines, I suspect in the early 90s when Windows 1.0 came out, people lost the connection between here is the physical hardware, here is the operating system, the shell environment that lives on top of that, and on top of that, if you really need to, there's a GUI for visualization. I think from that point onwards was a downfall of people having general knowledge about the architecture of computing, and that flows onto researchers as well. So quite often we do get researchers who turn up, and this is for the first time ever that they are confronted with having to use the command line. I mean, they've been told, right, my data sets are too big, right, for my personal device. They discover that their problems are too complex, and they're tired of actually having to leave their laptop running over the weekend because it's churning its way through some job or another. And that's a fairly significant issue. And it gets worse because the processing capabilities of individual cores is being surpassed by problem complexity and by data size, especially data size. And that problem is going to continue. Right, there is all sorts of nice little technical and physics reasons why we just cannot keep up the ability to process with the data speed, with the data volume. So clever attempts to get around. In fact, I've spoken to eResearch NZ about that in the past. But people try to find ways around it. Cloud technologies are one way around it. Push all that data away to get somebody else to do it. Open on demand provides this nice little, lower barrier of immediate entry. But ultimately, whilst you can use these tools, that lower the threshold to actually get onto computation that you need. they will always, and I emphasise that always statement, for physical reasons, for reasons of physical reality, hence the XKCD cartoon, they will always be suboptimal in performance. Behind every GUI is a command line statement. It's a constrained statement. You cannot get around this. So several years ago now, a few years ago now, Hugh Shanahan was at this conference in Sydney, and one of the Vox Pop questions came up: shouldn't we be building more modern tools and using 30-plus-year-old commands? And his response: oh, get serious and grow up. And people went, oh, that's a bit rude. And so nobody's right. You are not going to get around a situation where command line tools are ever going to go away. That is an absolute reality. Right, when I'm dead and buried in a box one day, we'll still be using grep, we'll still be using sed. Those things are going to be around forever. And part of that is because they were built under very sound principles. They were built on principles of we're going to have a small application, it's going to do one thing well, it's extensible with options, and it plays nice with others. And that's the foundation of where we actually start talking about where we're going to take researchers on their journey. You will get your research done in a more timely manner if you spend a couple of days, that's what it takes, a couple of days to learn these tools. And it's the beginning of that journey, because of course, as we probably all know in this room, once you actually begin to learn command line tools, you'll be learning them for the rest of your life because there are thousands of them with your various options. But at least you've got enough to navigate your way around and do your job submission and load your environment modules and things like that. So that is when we move into the world of advanced adult education and how we get these people involved. So that's a summary of an entire postgraduate degree there, albeit just a slice of it. What makes advanced adult learners different to people who are maybe undergraduates, high school students, primary school students, what have you? And those main components always have to keep on coming back to them. Autonomy in direction of learning. They are here because they want to be here. They have turned up to a high-performance computing workshop because it fits their needs, not because somebody told them you have to go to school. They've got those intrinsic motivations they want to learn rather than those extrinsic ones. They've got their own personal experiences of resource. They have come here for their problems to be solved. And they also are equals. When you get people turning up and saying, I've got this string of positions and degrees and papers and things like that, I'm here to learn high performance computing. Well, quite often they're actually more qualified than the person at the front saying, hey, this is what we're going to learn. So having a particular recognition of this, and also sensitivity to some cultural differences as well, because some people have been brought up in environments where you give great deferment to the person doing the educating rather than the person being educated. But in general, you're going to find that advanced adult education is a very different kettle of fish. And a few things there about the content you deliver, very super important. I have seen a number of times where people come out who have got excellent technical knowledge, but are unable to deliver the content in a manner which is sensitive to a person who doesn't have that knowledge. So that structured, dependency-based thinking. So I say, I'm not going to introduce anything new without the person knowing the prerequisites beforehand to that understanding, that structural knowledge. Also, grounding it in theory, grounding it in storytelling, making it memorable, and grounding it with, I've got 5 minutes, cool, I can zip my way through here, and also grounding it with their experience, always inviting that experience back into them, and using discipline-based learning styles. There was a bit of a thing 15, 20 years ago about individuals have got their own individual learning styles. Well, actually, no, it turns out disciplines have got learning styles. It's a bit hard to teach dancing from book learning, but people who like book learning might end up being quite good at history, for example. Okay, so what do? We have got day-length onboarding workshops. The basic ones are Intro to Linux High Performance Computing, Advanced Linux and Shell Scripting. It is software carpentry, but for HPC. That is where most people end up. We do have a range of more specialist ones. These ones normally have 50 or so people turn up to them. We run them about every second month. The others, we alternate with the others as well. Parallel high performance Python, very popular. regex, little bit less popular. Parallel programming goes into OpenMP and MPI, and so on and so forth. We also replicate a lot of the content and massage it appropriately for specialist versions. Bioinformatics, mech eng, and neuroscience being examples, and in person via Zoom, mostly via Zoom these days, is actually find that the asynchronous approach is a very, very effective one. On top of that, we've got a Spartan Champions program. This is where we get the people who are excellent, experienced users who are involved in a project, and if they are engaging in helping other people in their project use the system, they get access to a priority queue. That's the quid pro quo. You teach your fellow researchers, we'll give you access. That makes things easier for you, and we tie that in with our technical presentations. That's actually something that's really good for our staff. They can get to see the outcomes of the kit that they maintain in real-world situations, and quite often people throw in suggestions on how to actually improve things further. A mountain of documentation that we give as well. So we've got a great little apps examples directory. It's got something like 140 different applications that we give job submission examples for as well, including a fairly significant genomics one, which we've pinched from largely from data carpentry people, and also from the Swedish Academy of Agricultural Sciences, and actually gave some feedback on updating some of their examples that they had there as well. And this comes down to the actual needs of bioinformaticians themselves. What is different about bioinformaticians compared to your general HPC user? Well, quite often that comes to things like data transfer, right? So we have media flux, and we have a data team. So we include more on that need, and of course we pick applications which are bioinformatics based rather than what you get in the normal general course. We especially pay attention to those last things. Process locally, back up remotely, get your data, and Grace Hopper's great statement, mind your nanoseconds. If you haven't ever seen that video, I do highly recommend it. Go find it on YouTube. Grace Hopper saying mind your nanoseconds, and why it's really important to do your data process, get your data close to the processor. Okay. Very cool. Conclusions. I'm already at conclusions. Okay, so here are the important conclusions. Just providing HPC is empirically shown to actually generate research output, greater research output. HPC has got extraordinary returns on investment. There's been a couple of macroeconomic studies indicating $44 to 1. The Supercomputer Asia last year, the person from Japan was basically told that the government said, can you tell us the return on investment there? Came back and said it was $93 to 1. Very important and contextually appropriate statement in this one is, imagine the world thinking of COVID-19 without supercomputers. There was no way that we would have a vaccine today. We wouldn't be in the room. The other thing is that we've noted, I've done this little bit of research in the past, that both at VPAC and at UniMelb, that providing training generates more usage of the system. Who would have thought? And, there you can see it's like the results at RMIT, divergence in training hours and people being enrolled and usage. The one that I did in 2023, did in 24, but in 23, really surprised by that. I was actually expecting that number to be around about 25%. Turned out that over 54%, at least, because I realised that I actually left out one major 400-person course, of cluster utilisation was actually conducted by people after they'd received training. So HPC training generates HPC results. HPC results are I still think, the major and most important driver for research, computational research output. You've got to get the right people. Yes, there isn't many people out there who are both who do higher education and HPC work at the same time, but find them. And a very important takeaway is that you absolutely need this. You need to invest in HPC themselves and user education, and those institutions that don't do that will not survive because other institutions will, and they will be ahead of the game. So, on that note, it can apply anywhere, even in geometry. And thank you very much.
Thanks, Gary. Any comments and questions? We may have one or two questions.
Questions?
It seems that's really successful for the HPC training at Melbourne.
Thank you.
So I would like to ask, what's the most challenge you have been dealing with teaching those advanced adults?
Every time you run a session, it is engagement is really, really good, and encouraging that engagement is something which one has to introduce into the program, throwing spot questions out to people, inviting that engagement to come in. Particularly when there are, I was referring to those cultural differences that you do encounter, so getting people to feel that they can speak up and ask a question, even though they're dealing with supercomputing and this may be new and scary to them, that there is going to be no bad questions. The other thing is what I found on that second last slide at the very at the end there, trying to find people who are into high performance computing who are also wanting to do user education. That has been such a challenge, right? For many years now, I've been fishing around trying to find saying, so would you be interested in doing the intro to HPC class? No. So that's probably the biggest challenge I think is going to be faced.
Briefly on that point, do you think that might be that there can be more training for the educators? Do you think it might be a fear barrier that there's preference, but there's also the feeling that you just don't know what you need to do?
Yeah, sure.
So train the trainer, that kind of thing. Do you feel that could work?
Yeah, I think you're right, and a part of it is because and I've spoken about this before, is that somewhere along the way, high performance computing, it has become more and more popular. Since Greg Wilson did his little famous paper on HPC considered harmful, and more people have come into the HPC space, but universities have not really taught HPC. Except for maybe on a postgrad level for people who are doing computer science. So that that component which says, okay, go off and learn how to submit your job to the cluster, has been left to the HPC centres themselves. And let's face it, they've been pretty busy managing the HPC before suddenly they've got all these researchers that have come in who've gone, I don't know how to use this, I'm going to run sudo apt remove Python on the login node without knowing why they can't do that. There is a bit of a thing which I think the university system really needs to integrate, if they're going to take bioinformatics seriously or anything like that, they need to integrate a little bit of sort of like, and if you are going to be doing sort of like some work for your assignment, here is like, a 5-pager and sort of like, note, or maybe a lecture on sort of like the basics of sort of like getting onto a system and sort of like launching a job, because it'll be part of your assignment.
Thanks, Lev.